What you're looking at here is a level 1 solar electrical system put into a Chevy Express van. I got this van previously modified with an air conditioner and a refrigerator, and it has absolutely no modifications from the outside that make it look anything other than factory. Which would be absolutely fantastic if you're going somewhere that doesn't allow for RVs, but you really just wanted to sleep somewhere. And in this particular vehicle, you could do so with the air conditioner or the heater running all night long. Something typically impossible, because you would need like 800 amp hours of 12 volt batteries to run that. And you still would if you were using lead acid batteries. But using lithium batteries, that's a game changer. You're able to get such incredibly high energy densities. So I gotta have it set up here. This is the typical lithium iron phosphate battery that you'd put into a camper van. And this is a Samsung medical battery pack. Both of these are 400 watt hours, but obviously this medical pack right here is amazingly higher energy density. Than that lithium iron phosphate battery. So we're talking game-changing, big difference. And because the cells are so small, I was able to play Tetris and actually fit them in the wheel well here and take up absolutely no usable space, because on top of this wooden platform sits a mattress, and the space underneath here is pretty much ignored or entirely unusable. And I was able to get 5 kilowatt hours, 5,000 watt hours of lithium batteries entirely in that unusable space, which is just quite frankly amazing. And I have everything hooked up to the here. You have your breaker for your solar and your battery, and then your load. And your load actually is the output to the 12 volt. And I even added in an XT60 connector so that you can use that cable there and use the solar on the roof to charge the EcoFlow Delta, what they call a portable solar generator. It's basically pretty much the smaller version of what we have here, which is a 2,000 watt inverter and a rapid charging lithium battery, and a lot of different input and output options. So pretty much exactly the same thing here, but bigger. This is 1 kilowatt hour and ours is 5. So that's designed to run this air conditioner or a heater for an entire night. But this size battery would also be used for like a Class A motorhome to run the refrigerator and the cooking and the TVs and the laptops all day long as well, because 5 kilowatt hours is a lot of power. So that runs into this solar controller here. Let's see how much power we're currently getting in. Only about 320 watts, which is a little low, but it's still fairly early in the morning here, and we should see this creep up to around 420. Even though that's nowhere near 750 watts, in my experience with the flexible panels, you typically only get about 50%, whereas in a rigid panel, I typically see around 75-80%. And the load output of this, currently 570 watts, runs across the roof into the solar input of this, which is 520 watts. So we're losing about 50 watts through the wire there. So we're still above 90% efficiency, because we're using the solar controller here as a step down to take power from the 30 volt battery and send it to the 12 volt battery so that we can run this inverter right here, which is currently powering the air conditioner. The reason I went with a 12 volt inverter versus a custom 30 volt inverter was that when the vehicle is running and we flip that switch, the power from the alternator will be sent to the existing 12 volt house battery. So we would be able to run this even with all of the batteries dead. Now, I don't believe that we're going to be able to try to pull 700 watts from the alternator, but if you were to run something like a laptop or a cell phone or something else, or it would work just fine. In fact, I'm going to go ahead and pause this video and plug this in just to show you how much power it can pull.